All right, I know that this question looks like a lot. I can barely fit it on the page here. But remember, just follow instructions. Try to take it one piece at a time. Slow is okay. I know it's the last question, so you might not have a lot of time. But if you're not rushing, this is, you can definitely get this. If you are rushing, this might be better to just like go back and honestly check your work on something else. But here, we'll go through it. If Miss Simon starts her drive at 6:30 a.m., she can drive at her average driving speed with no traffic delay for each segment of the drive. If she starts her drive at 7 a.m., the travel time from the freeway entrance to the freeway exit increases by 33%. So freeway entrance to freeway exit, so that's 33%. Due to slower traffic. But the travel time for each of the other two segments of her drive does not change. So no change here or here. Based on the table, how many more minutes does Miss Simon take to arrive at her workplace if she starts her drive at 7 a.m. than if she starts her drive at 6:30 a.m.? So I'm going to ignore these parts of her drive because those are not changing, right? So this dramatically reduces the complexity of this question, right? So those things are constant. So I'm not interested in them. They don't affect my answer because they're going to be the same whether she's at 6:30 or 7, right? So this helps you just narrow your focus a little bit to the stuff that matters. So what do we need to do? We need to think about time. And for the previous question, we saw that we need to memorize the formula that speed is represented by distance over time. So we have a distance and we have a time. So let's see what's going on. Or sorry, we have a distance and we have a speed. So let's see what's going on with her time for this segment under normal conditions, right? So the speed is 50. That's 50 miles per hour, right? So we have the units right. The distance is 15.4 miles, and we do not know the time. So we're going to have to solve, and we can do that by multiplying both sides by t. That cancels that out, and then we're going to need to divide by 50. Ugh. So I'm just trying to squeeze it all in here. So 15.4 divided by 50 is 0.308. Pay attention to the units though, right? They told us to pay attention because they underline the word minutes. So this is going to be hours. I'm going to wait to convert it because I can do it at the end, but it's still part of my brain that it's there. I need to convert it. So now what happens? Well, the time increases by 33%. So I don't need to deal anything with the speed. The distance isn't going to change. I'm going to deal directly with this 0.308 hours. So I'm going to use my open formula so I don't get confused. My original value is 0.308. That's the O. The percentage is an increase of 33%. Right? So the open formula, that P stands for percentage. Sometimes it's just the plain old percent. But if I'm dealing with an increase or a decrease, I think of it as a 1 plus or minus the percentage. So I can do all my work in one step. E stands for equals, and N stands for the new value. So I'm solving for like the traditional thing that I'm solving for. So 0.308. In fact, I guess I'm kind of doing a little extra work here. That's okay. It's better to show you guys that open formula a little bit. 1.33, and so we get a new value of 0.40964 hours. So now I need to find the difference, right? Based on the table, how many more minutes does Miss Simon take to arrive at her workplace? So I have this is the original, this is the new. So I can subtract the two. So 0.40964 minus 0.308 is 0.10164 hours. And then we can just multiply that by 60. Let's do it. Yeah, let's do it in a different color. Times 60 to get the total number of minutes, which is 6.0984. And they say round your answer to the nearest minute. So 6. So I did do a little bit of extra work there. I could have taken a shortcut. I just kind of got in the zone there about the open formula and reminding you about percentages, because we have seen that a lot on this test, so it was a good opportunity to remind you of my formula for that. But we could have just gone with a 33%, right? So a 33% increase is going to be the same as finding the 33% because they wanted that difference anyway. So I could have just kind of cut that off and done 33% of 0.308 and then converted it. But I would have gotten the same answer. It doesn't really add that much work, so I don't really feel too bad about it. But notice, yeah, there's a lot of steps. It's a little bit of a pain in the neck, this question. But we did do a little bit of a cut at the beginning by going through and recognizing what was changing and what we were supposed to be focused on. And a lot of the sentences in this question are irrelevant or telling us about the numbers that are irrelevant in the original problem. So sometimes all that extra information is really good because it removes information for you. Do your best on this. It's not a high priority question. It's really weird, but if you have the time at the end, it's definitely gettable with just some persistence.